Hey students, I got a question here, number 21. Thought I'd make a quick video solution. And with that said, let me encourage you, if you have not, to watch my video before this one that helps clarify between U prime, and V, and how to clarify those ones. I think that will help here. I'm going to use that as a springboard. Let's just read number 21. 21 says, repeat the previous problems, so number 20, that's why I printed it, with the ship heading directly away from the Earth. So somewhere in here is planet Earth, okay? So I'll make kind of this Earth. And it says away. But let's go back to 20 here. It says, suppose a spaceship is heading towards the Earth at 0.75 C. Now, in mine, it says, repeat the previous heading away from the Earth. So I'm going to take a spaceship and say it is heading away from the Earth at 0.75 C. Now, what's important here is 0.75 C as measured by what? And I think they mean by the person in the Earth here, because it says, this one says heading straight towards the Earth at 0.75 C can shoot a canister at 0.5 C relative to the ship. What is the velocity of the canister relative to the Earth if it is shot directly at the Earth? So I guess we could kind of interpret this a little different, but I interpret that we're still shooting the canister at 0.5 C. And it's away from the ship. And so in this case, we're shooting it behind us. And so we're kind of like leaving a message, if you will. We're leaving the Earth here, and then we're shooting a canister behind us. Okay? And then it says here, oh, shot directly away. So it has us do both. My apologies here. So what is the velocity of the canister? Okay. And so we have a U prime, and a V. And if you watched my previous video, I emphasized conceptually and mathematically, and sometimes they're in conflict with each other, but the equation that connects the two together are the U equals V plus U prime over 1 plus V U prime C squared. And mathematically, the best way to approach this is to let the unknown be the U, because if we know these two, it's plug and chug. On the other hand, if the V or the U prime are unknown, then we've got, because it's top and bottom, we got to do some cross multiplication and a lot of algebra to figure out what those are. And that might conflict with what is the natural setting. I don't think it does in this problem. So let me do, quote unquote, the natural setting. And by the natural setting, I would say, let's pick the Earth as our reference or our first observer, and we'll call that the reference observer. The non-reference observer is the spaceship. And the object itself is the canister. So with that definition, the U would be the speed of this canister as seen from Earth. because the definition of u is the speed of the object as seen by the reference. And that's the question. What is the velocity of the canister relative to the Earth? And that means that this kind of natural way of saying, okay, let's take the Earth as not moving, which, again, that's a terrible way to say it because the Earth is moving. But if we take it as its reference, then I think the other things are moving relative to the Earth, and that's kind of a natural setting. So I think I can easily visually see u prime and the v. And likewise, it's perfect mathematically. So in that case, they work out great. So let's fill in what we do know. The u prime is then the speed of the canister as seen by the non-reference observer. Okay, so in my picture, the canister is moving, if I picture myself in the spaceship, I would see the canister moving away from me at 0.5 c. And it's moving to the right, so that'd be a plus. And then the v is the velocity of the two observers, so the reference observer and the non-reference observer. But it's marked and labeled as seen by the reference. And so the reference person, the person on Earth, does see the other observer, the person in the spaceship, moving to the left. So that would be negative 0.5 c. And then so if we put this in, we get a negative 0.75 c. And then we get a plus 0.5 c. And downstairs, we get 1 plus, and then we get the velocity of this 0.75 c with a negative. And then we get the u prime as a plus 0.5 c all over c squared. Now you can see why we like labeling them in terms of the percentage of the speed of light. Because in the top, this would be a negative 0.25 c. And in the bottom here, the c's would cancel off. And so if I grab a calculator here, this is going to go 1 minus, and I'll have a 0.75 times a 0.5. And so this would be a 0.375. And so negative 0.25 c over 1 minus the last answer, 0.625. And then 0.25 divided by that last answer is 0.4 c. Okay, oh, negative. And so there would be the answer to A. Now, B can follow that same description, where B says if it is shot directly away from the Earth. So I'm going to put the canister at a 0.5 in that direction, maybe cross this out. And what that would do is tell me my u prime has changed. My v, which is the velocity of the non-reference observer relative to the Earth, is still my negative 0.75 c. And this time, the u prime is a plus. I'm sorry. Let's see, the observer going this way, negative 0.5 c, because again, from this non-observer, the canister is going left, going negative. And I'm still looking for the u. What is the velocity of the canister? So in this case, using the same equation, I would go u, and then I'd put in the v, which is negative 0.75 c. And then add to that the negative 0.5 c. Divide that by 1 plus, and then I'll have a negative 0.5 c times a negative 0.5 c all over c squared. the two negatives combine to give me 1.25c negative. And in this case, again, the c's cancel off. That's great. And then I would get down here in the denominator the 0.75 times the 0.5, and I would be adding it to a 1 this time because the two negatives make a positive. So this is 1.375. Finishing up with a final answer of 1.25 divided by that last answer of 0.909c, and in the negative direction. Now, I probably should point out before I finish this that the problem just said away from the Earth, and I picked this side of the Earth. We could have easily have done this, and a lot of our pluses and minuses would be different, and that's not, and that's not really relevant. But I got two negative speeds because I picked it moving this way to the left, and you could easily get two positives. So maybe I should check the solution and see if they got positives or negatives, but that's kind of irrelevant. These are the two answers. All right, I hope that helps. Number 21. Take care.